Alrighty, everybody, it's about that time to get started with the last planetarium show of the day. So for now, I'm going to be putting away our space trivia questions because now we're going to be heading into the unknown. Ooh. And good afternoon, everybody. Welcome to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter. And just a heads up, I'm not just a voice coming out of the walls. I'm actually a person, and I'm standing right behind you. Hey, how's it going, everybody? He. Don't hurt your necks. Look forward into the dome before you. That's where the whole show's going to be. I just want to let you know that I'm here. I'm an actual person and not a robot. And everything that you see in purple right now, folks, is going to be the entirety of the planetarium screen. And it's put on thanks to 6 different projectors hidden throughout our planetarium dome. If you're looking for those projectors, they're hidden just below that purple glow. And folks, the show that we're going to be doing right now is by far one of my favorites to do. This one's different from all the other shows that we've done here in the Morrison today. This one's called Tour of the Universe. And with Tour of the Universe, this show is completely live, so you're going to hear my voice for the next 30 minutes. And what this entails, well, we're going to be starting off pretty close to the Earth, and we're going to be zooming all the way out to the very edge of the observable universe. So hopefully by the end of the show, you won't have an existential crisis of where we are in space. But just a forewarning, we're pretty small in the grand scheme of things. And before we get started, folks, I do have to go over some quick house rules just so that we're all on the same page and have an enjoyable time. There's quite a few of us in here. First off, there's no food or drinks allowed in. If you manage to bring any snacks, make sure those are put away till the end of the show. We want to keep the theater as clean as possible. We really do appreciate it. Also, if you happen to have any cell phones, smartwatches, tablets, anything that produces really bright white light or loud sound, now's the time to turn them off, deactivate them, put them away for the next 30 minutes, as these could be very distracting, not only for you, but for the folks sitting behind you. Really takes away from the planetarium show. And also, folks, if you need to exit early during our show, you're more than welcome to do so. All we ask is that you exit towards the top of the planetarium. That's where the exits are going to be before, during, and after the show. So when in doubt, always make your way up the stairs. Although if you're a person that has trouble climbing the stairs, don't worry. We understand the stairs are very steep. So once the show finishes, just remain seated for a little bit longer. We'll have a staff member escort you to a lower exit once the show finishes up. And last but not least, folks, this show is very immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy trick to ground yourself. All you got to do is close your eyes, take a few big deep breaths, then your brain will remember that you're sitting in a planetarium in San Francisco and not flying across the universe, at least not more than the usual. He. But with that being said, we are ready to go. We're just waiting for the last few folks to put away those cell phones before we begin. Alrighty, folks, it looks like we're ready to start. So I invite y'all to sit back, relax, and let's begin our tour of the universe. Alrighty, everybody. As I mentioned, we're going to be starting off pretty close to the Earth at this really cool spacecraft right in front of us called the International Space Station, or the ISS. And we can see all the city lights down below, so we can see the curvature of the Earth. And a lot of people tend to ask me, hey, Christian, what is the International Space Station? I hear about it all the time in news and articles, but I don't really know what it is. Could you explain it for me? Well, of course, folks. The International Space Station is a research facility, a laboratory that orbits around our Earth. And they conduct all different types of science experiments that they're unable to do on our planet, which has a lot of gravity. So some of the different experiments that they'll conduct up here are things like what happens when you try to grow plants in space? Do the plants grow the same? Do they grow differently? Which way do the roots grow since there's less gravity up here? And another one is something like what happens when you try to spark a match in space? Does the flame act the same? Does that act differently with less gravity? And one of my favorites is where they had 2 identical twins. One twin lived on Earth for about a year, the other one lived on the International Space Station for a year. After that year, they compared and contrasted. Turns out when you live in space for a long period of time, you tend to age a little bit slower, but not only that, you also lose a lot of muscle because you don't have gravity constantly working down on your muscles all the time, or at least not as much. And just to let you know, folks, the International Space Station looks really big on our planetarium screen right now, but it's not that big in actuality. It's only about the size of an American football field. If you've never been to an American football game, don't worry. You can also use the entire California Academy of Sciences, the museum that we're sitting in right now. That's about how big it is. And also, what's really impressive is that this thing is going incredibly fast. The International Space Station's traveling at a whopping 17,000 miles per hour. Whew. Where it orbits once around the Earth every 90 minutes, where it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And also, it looks really far away from our planet, but the International Space Station isn't too far away. It's only about 225 miles above the surface of our world. 225 miles, that's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend, so not too bad. But to tell you the truth, folks, this is as far as we put humans into space, only 225 miles above our world. The reason why? Well, it's very expensive. You got to build yourself a rocket ship or buy yourself one, and then when you get your hands on that, you have to account for a lot of rocket fuel. You're going to need so much rocket fuel, you're going to be able to escape the Earth's gravity. And once you acquire that rocket fuel, you have to also account for all the food, water, all the air you're going to be breathing while you're out here in space. So the bill gets quite costly quite rapidly. But folks, the International Space Station is just the first stop on our tour of the universe. So now we're going to see it slowly disappear compared to the city lights down below. And before we lose track of the International Space Station, I want to add a nice little orbital path so we can see it as it slowly fades away. Alrighty, folks, now we zoom so far out, we're now looking down at our entire planet Earth. And I want to let you know that the space program that I'm using here in the Morrison Planetarium is something that you can go home and download if you want to fly through space, just like how I am. And the space program that I'm using here is something called OpenSpace. So if you go to your favorite search engine, type in OpenSpace project, you can find the link where you can download this program, and it's a whole lot of fun. But just a heads up, this program is in its beta phase, which means it's not completely finished. We may come across a few bugs and glitches. If we do, I'll point them out. Hopefully we can look past them. And also, OpenSpace uses a whole lot of processing power and needs a lot of storage space. So if you have an older computer, I wouldn't recommend downloading it. But if you got something new or a gaming computer, give it a try. It's a whole lot of fun. But if you're a person like me that doesn't want to download anything and just doesn't have enough space on their storage, because I never delete anything, well, we also have another great alternative called NASA's Eyes. So if you go to your favorite search engine, type in NASA's Eyes, like the human eyeball, you can find the link, don't have to download anything, and you can fly through space, and it's so much fun. So we got OpenSpace Project and NASA's Eyes. But now that we got a good sense of what we're using here in the Morrison Planetarium, let's make our way over to our nearest natural neighbor to us in space, the Moon. Alrighty, folks, so we humans have been to the Moon before. That was between 1969 and 1972, thanks to NASA's 6 Apollo missions that brought a total of 12 incredibly lucky guys to walk on the surface of the Moon. They got to conduct science here, and of course, they had some fun as well. They got to play some golf up here. But again, last time we sent humans to the Moon was 1972, a little more than 50 years ago or so. But don't worry, folks, we humans are making a return trip back to the Moon in the next few years, thanks to NASA's new space mission in the works called Artemis. Pretty much with Artemis, NASA wants to send humans to Mars, but before we send humans deep into our solar system, we got to figure out exactly how we're going to live out here in space. So the Moon is the perfect stepping stone to figuring out all the logistics of how we'll be doing that. And also, our technology has greatly improved in the last 50 years, so we're able to go conduct a lot more science in a much more compactable way. And not only that, we also want to set up a base, or many bases throughout the Moon. And one definitely good place that we want to set up a base is the south pole of the Moon, because we found a good deal of ice. And ice is going to be very beneficial for setting up lunar bases. You can pass an electric current through it, separate the oxygen and the hydrogen, and both those elements are very useful. But again, look out for any news about Artemis in the coming years. We humans should be making a return trip relatively soon. And also, folks, when we look at the Moon here from Earth, sometimes the Moon feels really, really close. Feels like you can reach out your arms and touch it. But the moon is incredibly far away from us. It's about 240,000 miles away from the Earth. Whew, 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for about 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on out, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities because space is so big. So astronomers use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind. So everybody say bye-bye, moon. We'll see you later. And now, folks, we're going to start to see the moon and the Earth as they start to slowly disappear. And before we lose track of them, I want to add a nice little planet trail because you can easily lose stuff out here in space. And on our journey today, folks, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to computer models like OpenSpace showing us the most accurate images and information available to us. And now, any moment now, the nearest star to us, the sun, should be coming into view. So here comes the sun. Do. And folks, the sun is also incredibly far away from us here on Earth. The sun's about 93 million miles away. Whew, 93 million miles. That's a good distance away. So remember, we're the third rock from the sun. So we got 1, 2, 3. That's us right over there. 93 million miles between us. But in terms of speed of light, that's not too far. In order for sunlight to travel that distance, it only takes sunlight about 8.5 minutes at the speed of light to cross that distance. So 8.5 minutes, not too bad. But now that we have a nice bird's eye perspective of our solar system, let's get a quick refresher of what's inside of our solar system, because there's a lot of good stuff here. Right in the middle of our solar system, we got our star, the sun. Closest planet to the sun, we've got Mercury. Then we have Venus, Earth, that's us, and then Mars. These are the rocky terrestrial planets. These are places where we can actually land a spacecraft on. And then past the orbit of Mars, we have this really cool thing called the main asteroid belts. And this is what it would look like if I highlight all the asteroids in our asteroid belts. There is a lot of them. And then past the asteroid belt, we have the really big planets, the gas giants. We've got Jupiter right over here, the biggest of them all. Then we have Saturn, famous for its rings. And then past them, we have our icy gas giants. We got Uranus, the funny one, and Neptune. And of course, we can add everyone's favorite and lovable dwarf planet, Pluto. So here's the orbit of Pluto coming on screen, just on the bottom right. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belts. And you're probably wondering, what's the Kuiper Belt? I've never heard of that before. Well, folks, the Kuiper Belt's going to be all this stuff. So the Kuiper Belt is like a second asteroid belt past the orbit of Neptune. And what you're mostly going to find out here are mostly icy asteroids and short period comets. Comets that don't stray too far away from the sun. And pretty much we came across more than 400 objects out here in the Kuiper Belt region in 2006. And that's the really cool thing about science, because as our technology gets better and as our telescopes get better, we're able to see much further objects, much smaller objects as well. We get to observe and get a better understanding of what's around us. So maybe in the next 5 to 10 years, as our telescopes get better, maybe we'll find more stuff out here in this outer part of our solar system in our own backyard, which is just so cool to think. But I want to put away the Kuiper Belt because that's just a whole lot to look at. And now, folks, I'm going to be adding on screen some of the many different spacecrafts we sent out in the 1970s to explore our solar system. So now on screen, we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. We can see that interaction on the bottom right over there. Now, all of these spacecrafts are all traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventurers, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, it takes sunlight about 5 hours at the speed of light. 5 hours, not too bad as well. But folks, let's leave our planetary scale behind us because now we're going to be heading into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. Alrighty, folks. So now we're here in interstellar space, and so again, we're right in the middle. That's our star, our solar system. The closest star system to us is Alpha Centauri, which is this one over here on the left-hand side. You can see it moving. And again, 4 years at the speed of light to get all the way out here. But that doesn't really put into perspective of how long it would take us humans to travel that distance. Well, folks, if you're getting a rocket ship today, left planet Earth, made your way over to Alpha Centauri, it's going to take you about 8,500 years to cross that distance. And that's just a one-way trip. Whew. But let's stop and consider whether humanity has made its presence known beyond our solar system, because now we're going to be stepping inside something called the radiosphere. So again, folks, we are now inside something called the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. And this first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they are traveling at the speed of light. So this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is always expanding at the rate of 1 light year per year. So is anybody out there listening? And right now, folks, I'm going to be adding some many markers onto the screen. These many markers indicate some of the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found more than 5,000 exoplanets in the nearby vicinity to us, 5,000 other worlds besides our own. And that 5,000 number is going to be increasing as the years continue because we have space telescopes where their whole purpose is to find as many exoplanets as possible. So they're constantly scanning the night sky. In fact, if we look over to the left-hand side of our screen, you can see that we pointed our space telescopes in one direction and we found a whole heap of exoplanets in just that portion of the night sky. So again, as they scan more, we're going to be finding exoplanets left and right. So that 5,000 number is going to be going up. Now, to say if any of them are Earth-like with conditions suitable for life as we know it, well, we cannot answer that question quite yet. Pretty much new space telescopes are being developed right now, built. So those are on the drawing boards, and then they need to be constructed and then launched into space. So we've got a little while before we can answer that question. But the more important point here is that quite a few of these planetary systems are within that 90 light-year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we live in a star system on the left hand right over here. We find an alien civilization somewhere on the right hand side. Let's say this one right here. We shoot them a text message. We say, hey, we live here. Takes 60 years to get to them. They listen in, answer back another 60 years. Folks, that is a 120-year conversation in the making. Whew. And I could barely wait for a text message from my friend. But of course, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, folks, I'm going to be putting away our exoplanet markers. And I want to leave our radiosphere up on screen. As huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way galaxy. So keep your eyes on that radiosphere as we continue zooming out. Alrighty, folks, we're now looking down at our Milky Way galaxy, and I've got to ask, can anybody see their house from here? Just kidding. Folks, we are now looking down at our Milky Way galaxy, and our galaxy is incredibly large. If you wanted to cross it from one side to the other, it's going to take you about 130,000 years at the speed of light. Whew, that is a good distance as well. And not only that, our Milky Way galaxy is so huge, we estimate that there's at least 300 billion stars in our galaxy. If our recent discovery of so many exoplanets just within our small neighborhood, within this vast star city, is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave our Milky Way galaxy, I want to show you what it looks like from a sideways perspective. So when we swing around, you're going to notice that we live in a big flat spiral disk, kind of looks like a big pancake. And when you look up in the night sky, you probably heard someone say, hey, look, you can see the Milky Way from here. What they're referring to is this, the plane of our Milky Way galaxy. That's what you're seeing up in the night sky. And this is important because when astronomers and scientists want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south instead of looking to the plane of the Milky Way, which has planets, stars, gas, debris, things that block their view of the universe. So again, we like to point our telescopes galactically north and south. Keep that in mind. That's going to come important in just a little bit. But folks, the Milky Way galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And we live in a local galaxy group which contains about 30 galaxies large and small, also includes the nearest large spiral to us, the Andromeda Galaxy. Only 2 million light years away, just next door, and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as we continue expanding out, folks, you're now going to realize that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, or they like to avoid each other where there's very few galaxies or no galaxies at all. So we can see a nice galaxy cluster on the right-hand side. We can see some galaxy clustering at the bottom right over here. We can see very few galaxies towards the top, or no galaxies at all, those voids. You can kind of think of galaxies like people. They like to hang out together, or they like to avoid each other. And folks, we zoom so far out now that the picture that we're looking at represents the closest 30,000 galaxies to us across a space over 300 million light years across. We got to give thanks to an amazing researcher, an astronomer by the name of Dr. Brent Tully, who works at the University of Hawaii, who compiled this amazing representation over decades of time alongside many other astronomers as well. So big shout out to Dr. Brent Tully and his team. And since we're all the way out here, I do want to show you the first photograph that was released by the James Webb Space Telescope, the brand new space telescope that surpassed Hubble. And folks, here is that first image. What we're looking at is something called the James Webb Deep Field image. And this photo is spectacular because what we're seeing here is a galaxy cluster right in the middle. And this galaxy cluster, these points right there in the middle, are so massive and have so much weight that they're causing this bubble effect called gravitational lensing. They're warping space and time itself. So it's creating the background galaxies to cause them to warp, duplicate, and distort. So we can see some galaxy distortion towards the bottom left. We can see some on the right-hand side and a really good one on the top right. What's even more impressive is that this photo that we're looking at, taken by the James Webb Space Telescope, only took about 12.5 hours to make, compared to the Hubble Deep Field image, which took 21 days. Our space telescopes are greatly improving, and I cannot wait to see what other images that will be releasing in the years to come. But let's put that away and continue with our tour of the universe. And now, folks, we're going to be heading out to a much larger realm of larger realm of our universe, because now we're going to be seeing the large-scale structure of the universe. And remember, every single point of light that you're seeing, that's not a star, that's an individual galaxy. And just to let you know, the large-scale structure of the universe is not shaped like a bow tie or a butterfly. Remember when I just mentioned that we live in a flat spiral disk of the Milky Way? Well, if we were to line up our Milky Way galaxy, it would line up just down the middle like so. So again, we like to point our telescopes galactically north and galactically south instead of looking to the plane of that Milky Way. But astronomers still want to make sure that there was galaxies through the plane of that Milky Way disk. So we have this nice purple survey of galaxies. You'll notice that we're still able to find them, just not as many and not as far. Pretty much we have to wait for our technology to improve, and once that happens, we'll be able to fill in all these areas that haven't been filled in yet. So it's just a matter of time. And unfortunately, folks, it looks like we're running drastically low on our tour of the universe, so we got to continue pressing on. 30 minutes is just not enough time to talk about the universe, to be honest. But now, folks, we're going to be encountering these really distant, faraway objects known as the quasars. And the quasars are going to be represented by these nice orange dots at the very edge of the large-scale structure of the universe. So we can see some quasars on the right, some quasars on the left. And quasars are short for quasi-stellar radio sources. These blazing objects are all billions of light years away, so now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe, and before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. Alrighty, folks, here we are at the very edge of the observable universe, and what we're looking at is something called the Cosmic Microwave Background Image, or the CMB image for short. All evidence indicates that the universe that we live in is about 13.8 billion years old, and this is data compiled by Planck and other radio telescopes. And the picture that we're looking at is the very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And what we're looking at is not a typical photo either. Instead, this is a temperature density image, where the light echoes of the Big Bang are color-coded, where the lighter areas correspond to the hottest, least dense regions, and those darker areas, the coolest, densest regions. These fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000. But these really small differences eventually gave rise to the large-scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, it looks like we've traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go, and that's going to be back towards planet Earth. So let's find a nice entry point through all these quasars and galaxies, and let's return back to planet Earth. Alrighty, everybody, we're crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. Now, we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But hey, look at that. Looks like we're now entering our Milky Way galaxy. We're heading straight for that radiosphere. And of course, we're making our way downtown, walking fast, faces past, and we're homebound. Da-na-na-na-na-na-na. And we're now entering our solar system, folks, passing the spacecrafts we sent out in the 1970s to explore our solar system, passing the Kuiper Belt in the orbit of Pluto, and making our way to the third rock from the sun, our homeworld planet Earth. All the people we've ever known, ever learned about in history, all lived on this one planet. And now it looks like we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And as we make our final approach back to planet Earth, folks, this is going to be the end of our Tour of the Universe show. And I want to thank y'all for stopping by and watching it with me today. I hope you did enjoy it. But hey, look at that. We made it back home safe and sound, planet Earth. And that's going to be the end of our show, folks. Thanks for stopping by, everybody. Have a great day.